So today we're going to learn what is called Pythagorean theorem. The name Pythagorean comes from the man who founded this theorem. And a theorem is something proven to be true. So in geometry next year, you're going to learn a lot of theorems because it's all about shapes and stuff that they've proven to be true. So just get used to this word theorem. Again, it means something proven to be true. Mr. Pythagoras was an ancient Greek mathematician, and he was playing with triangles, and he realized that a lot of times that these triangles have these squares attached to them, even if you can't see them. And so there's this picture at the bottom here. And what he realized is that every time it was a right triangle, that this theorem he came up with worked every single time. And so this is all about right triangles with these imaginary squares attached to them. So here you have a right triangle. Can you imagine a square attached here, here, and here? Yes. Okay, so that's kind of what he was playing with when he figured out this theorem. So what he decided to do is call the two sides of a right triangle that form the right angle, he called those legs. So this is a leg and this is a leg. And then the side across from the right angle, he called a hypotenuse. Don't ask me why he named it that, but that's what he named it. A hypotenuse. It is the biggest side of a right triangle, and it's always kind of looks like a diagonal, and that's what he called it. Pythagorean theorem is found on the 8th grade math star chart, and it says this: a squared plus b squared equals c squared. And that's what we're going to learn today. We're going to learn what each of these pieces represent and what they mean and how to use it. And so what Mr. Pythagoras said is the hypotenuse is always going to be side C. Like, you cannot change it. The hypotenuse has to be what? Side C, and then these two are your A and your B, and it does not matter which one is which. So if I do this as A and you do this as B, it does not matter. The only thing that matters is that the hypotenuse has to be side C for his formula. Everybody good? All right, so let's look at the bottom because this demonstrates what he figured out. So what he did is he was playing with these right triangles. And do y'all know that to get a square, you do side times side, and that gives you the area of a square, right? So if I have this side right here, and it's 3 units long, 1, 2, 3. What is 3 times 3? And so that is the size of a square that would be attached to a side that's 3 units long. Then right here I have a side of 4 units long, and what's 4 times 4? So I have a square that's 16 units, yes? And then over here, the hypotenuse is 5 units long. So if I wanted to attach a square to it, 5 times 5 is? And so that's what this shows. Is everybody good with what the picture is showing? What Mr. Pythagoras figured out is that every time there is a right triangle, the area of the two smaller squares will add up to equal the area of the bigger square. And it happens every single time. And so he kept playing with these right triangles to see if it was true. Does this happen every time? Is it only happening sometimes? And he realized it happens every single time. And that's why he came up with this theorem, and he named it after himself. That's why it's called Pythagorean theorem. So here's how it works. This is side A, this is side B, and this has to be side C. Are y'all with me? The theorem says a squared plus b squared equals c squared. A squared represents the area of the first small square. Are y'all with me? And then you add it to the area of the second small square, and it adds up to equal, what does it add up to equal? The area of the largest square. So the area of this square plus the area of this square has to equal the area of the largest square. Now, why do we care? We use Pythagorean theorem for multiple reasons. The first reason we use Pythagorean theorem is to identify a right triangle. So just looking at a triangle, if you know the three sides, you can plug it in and see if it works, and if it does work, it's a right triangle. If it doesn't, it's not. The other reason we use this is to solve for a missing side of a right triangle. Okay, so we use this for two reasons. All right, so let's just kind of explore with this. This side is 3, so is 3 squared plus, what's this side? What's this side length? 4, and if I square it, 4 squared, equal to the hypotenuse squared, 5 squared. Is this true, yes or no? Well, 3 squared is 9, and 4 squared is 16, and 5 squared is 25. Is 9 plus 16 equal to 25? Yes. So does this represent a true right triangle? Yes, because it works in Pythagorean theorem. Okay, so again, let's flip to the back, and we're going to see the two reasons we use Pythagorean theorem. All right, so we have this triangle here, and the question says, is it a right triangle? Well, we don't have something to measure the right angle. Does it look like a right triangle? Yeah, but that doesn't mean it is. So what you're going to do is use Pythagorean theorem to say, yes, it works, or no, it doesn't. So which one of these sides would have to be side C if this was a right triangle? 15, because it's the biggest side. So this would have to be the C. And then we could say this is the A and this is the B. It doesn't matter which way you say it. And then all you do is see if it's true or false by plugging it in. Is 12 squared plus 9 squared equal to 15 squared? Well, I would go check it in my calculator. So is 12 squared plus 9 squared, and then I would hit enter, which is 225. Is that equal to 15 squared? Yes, it is. So is this a right triangle? Yes, it is, because Pythagorean theorem was true. It did work on this. Are y'all good? Try this one on your own. Okay, this had to be the C if it's a right triangle because it's the biggest side. So you would say either A or B. It doesn't matter if you did it different than me. Is 32.5 squared plus 39 squared equal to 48.5 squared? So I say 32.5 squared plus 39 squared is 2577.25, and 48.5, is 2352.25. Do those equal? So this does not form a right triangle. Are y'all good? Yes or no? A lot of people in construction use this formula because they'll be building like big rooms or anything, and they want to make like an angle perfectly 90 degrees, but they don't have like an angle measure. They'll just take the side length and the side length and then use it, find the diagonal, and then they see if they formed a good right angle in that corner. Make sense? Yes? All right, the last thing that you can do to use this formula is to solve for a missing side. Now, this only works if you know it's a right triangle already. So they're telling you this is a right triangle. Solve for the missing side. So everybody look, what side is missing? A, B, or C? How do you know that's C? Because it's across from the right angle. If it's across from the right angle, it's side C. So you're going to write the formula down. A squared plus B squared equals C squared. And then you're going to plug in the pieces that you know. So I know that A, we'll call it 6. So 6 squared plus 8 squared equals C squared. And then you just solve the equation. Does this make sense? So I go to my calculator and I put in 6 squared plus 8 squared, which is 100. Yes or no? Everybody good? Equals C squared. Now, is that C or is that C squared? So basically what we just solved for is the area of this imaginary square that's attached to C. So if I want the side length, remember what I taught y'all, what's the opposite of squaring something? Square rooting. So you square root both sides, and C is equal to 10, because 10 times 10 is 100. All right, I want y'all to try this one on your, no, not that one. Try this one underneath it on your own. Find side C. Did everybody get 50? Now, a good way to check your answer is if you're solving for C, of course, it should always be bigger than the legs A and B. Yes? So when you're solving for C, you add those together. Yes? Questions? Now let's go solve for a leg. So everybody look at this next example. This is the right angle. Does everybody agree? So this side across from it has to be side C. So we'll call this missing side A, and the 15 will be B. So I have A squared plus B squared equals C squared. I don't know A, so I just say A squared plus 15 squared equals 21 squared. Are y'all with me? If I want to solve for this, wouldn't I have to get this to the other side of the equal sign? So instead of adding these two, what am I going to do? I'm going to subtract minus 15 squared, and that would cancel that out. So A squared is equal to whatever this is, 21 squared minus 15 squared. And y'all know where the shortcut button is right here, right? For squared. Okay. So 21 squared minus 15 squared is 216. Is that my answer, or is that the area of the square that's attached over here? That's the area. So what do I do to it to get the side length? Square root it. So A is equal to the square root of 216, which is 14.7 if we round. Oops, 14.7. Okay, I want y'all to try this one on your own. So since this is the right angle, this has to be side C. So I write my formula. I'll call whichever, this A, this B. It does not matter if you switched it. (10 squared minus 6 squared is 64. Is that my answer, or is that the area of a square? So I have to square root my answer, which is 8. What do y'all think? Super easy, right? Okay, so why does this matter to you? Because in geometry, you're going to deal with a lot of different shapes, and you're going to have a lot of missing pieces, and anytime you see a right triangle with a missing side, you can use this formula. Make sense? All right, again, the two ways you use this formula. First off, if they give you the 3 numbers, you say yes, it's a right triangle, or no, it's not, just by saying if it's true or not. And the second way you use it is to solve for a missing side, if a side is missing. But this only works for what kind of shape? Right triangles. All right, I'll pass out your assignment.